Algebraic reasoning, chapter 1.9, exercise 1 through 12. I'm going to go over mostly the odd number problems in this set. With the exception of this first set, for questions 1 through 6, use finite difference to determine if the data sets shown in the tables below represent a linear, exponential, quadratic, or cubic function. In this instance, I'm going to do 1, 3, and 4 instead of 1, 3, and 5 as I usually do. Well, the first thing I'm going to do, and I'm just going to do it out of habit, I'm going to evaluate, just kind of looking at this. If we add, we have 6 minus 3 plus 3, 12 minus 6 plus 6. We have 24 minus 12 plus 12. And you see how the differences are escalating? Plus 24. We definitely do not have a linear function here, and we do not either have a 6 minus 3 plus 3 or second differences plus 6. So even our second differences are multiplying by 2. So this section here has to do with cubic functions, and we see neither a linear, quadratic, or cubic function. And so by process elimination, looks like exponential. So our common ratio is equal to a sub n divided by a sub n minus 1. So we take any term divided by its predecessing term, in this case 6 over 3, we get 2. If we take next one, 12 over 6, we also get 2. So we say this is exponential. And that is our answer to problem 1. Next, we're going to look at problem 3. Okay, computer a little bit glitchy. All right. So the same type of process as the last one. I want to see if I can get a little pen here. These smaller lines. Okay. 8.75 minus 2.25. That's going to be plus 6.5. And next one we have is 15.25 minus 8.75. That's also going to be plus 6.5. Then we have 21.75 minus 15.25. That's plus 6.5, and so on down the line. So all of our first differences are plus 6.5. On the left, we're going up by 1 every time. So we conclude with our first differences are equal. I'll write that down. Equals 6.5. Therefore, linear. So we have a linear relation. Now, what I'm going to do is, instead of going to the next odd number problem 5, I'm going to go to the next problem 4, and it's going to be apparent shortly, I hope. So anyway, we're going to look at, we see on the left side, we're going up plus 1 every time. Now on the right side, 10 minus 5, that's going to be plus 5. Then we have 35 minus 10 is going to be plus 25. Then we have 92 minus 35. What is that going to be? That's going to be 50. Is that plus 57? Is that right? Yeah, I think so. Then we have 192 minus 92, that's going to be plus 106. Then we have 350 minus 198 would be plus 152. And then we go to our, we have definitely not linear. We go to our second difference, 25 minus 5, which is going to be plus 20. Then we have 57 minus 25, that's going to be plus 32, is that right? Yeah. Then 106 minus 57, that's going to be plus 59, I believe. Is that right? No, no, it's not. It's 49. Then we have 152 minus 106. That's going to be 42, is it? That doesn't look right, does it? Let's see, that's 106. Kind of messed up that last one there. No, it's 157. That's 101. Let me fix that here. Okay, and then we have 350 minus 193, that's going to be 157. So 101 minus 57, that's going to be 44. And we have 157 minus 101. That's going to be plus 56. I think we're in business now. If we take 32 minus 20, that's going to be plus 12. And 44 minus 32, that's plus 12. And 56 minus 44 plus 12. So we have third differences. Are equal to 12, therefore cubic. The cubic relation here. Okay, I wanted to show what a cubic relation looked like. That's why I went to 4 instead of 5. The next step I'm going to look at here is numbers 7 through 12. And 7 through 12, for questions 7 through 12, the data sets shown in the tables represent cubic functions. Use finite differences to determine the function that relates the variables. And at the upper right, I wrote f of x equals ax cubed plus bx squared plus cx plus d. So we're going to find out what these are. And we know that they're cubic. We know that on the left side we're going up by 1 and so on. Now, what we have initially is a y-intercept. So we know that in the numbers needed for the standard form, we know that d is going to be equal to -1. Okay. The first thing we're going to look for is the first differences. So 0 minus -1 is going to be +1. That's going to be a key number as we go forward here. Then we have 11 minus 0 is going to be +11. Then we have 50 minus 11, which is going to be +39. And we have 135 minus 50, which is going to be plus 85. And then we have the 284 minus 135. That's going to be, is it 149? Is that right? Sounds like I probably could use another calculator here. I'll press the numbers. Okay, second difference, we have 11 minus 1 is going to be plus 10. Then we have 39 minus 11 is going to be 28. Then we have 85 minus 39, that's going to be 46. And then we have 149 minus 85, that's going to be 64, is it? Yeah, I think it's going to be 64. So those are the second differences. Now the third differences, which we have to have equal to find our cubic function. We have 28 minus 10, so that's going to be plus 18. Then we have 46 minus 28 is going to be plus 18. And then we have 64 minus 46 is plus 18. And so we know that our equation is going to be that our third difference, I'm going to write it over here, is equal to 6a. And we have found that to be 18. So we say 18 is equal to 6a, and dividing by 6, we have a is 18 divided by 6, or a is equal to 3. So a is equal to 3, meaning we're going to have 3x cubed is going to be our first term. Next, the first second difference, I'll write this here. I'll write here, first second difference is equal to 6a plus 2b. And so what is that going to be? Our first second difference is going to be this 10. And what you're looking for is when you go from x from 0 to 1, the next one up there is 10. So our first second difference is 10. So 10 is equal to 6a plus 2b. Now we've already established that our 6a is our third difference, which is going to be 18. So 10 equals 18 plus 2b. And we subtract 18, we get negative 8 is equal to 2b. And dividing by 2, b is equal to negative 4. So I'm going to put b is equal to negative 4 up here. And the last thing we're going to have is first difference. And I'm going to circle that now in red. So that's 1. So we write down here, I'll write first difference is equal to a plus b plus c. So our first difference is 1. It's equal to a, and a we've established is 3, plus b, so minus 4, plus c. And if we just simplify here, we got 2, and on the right side we have 3 minus 4. No, I got that wrong. On the left side we have 1, we just bring down the 1. Right side we have 3 minus 4, which is negative 1, plus c. If we add 1 to both sides, we get c is equal to 2. So you have c is equal to 2. And so we have our equation here, our cubic function, and I'm going to have all the components up here, but to give room, I'm going to write this down below. We have f of x equals 3x cubed we have minus bx squared, so minus 4x squared, and plus cx, so that's going to be plus 2x, and we're going to have our d, which is minus 1. So this is going to be our answer to problem number 7. Okay, next odd number problem 9. Okay, this time, again, I'm going to just write what we're shooting for. We're shooting for f of x equals ax cubed plus bx squared plus cx plus d. In this case, we have a y-intercept of 0, so we have our value of d is equal to 0. So we're not going to have a constant term at the end of our function this time. Next, we're going to go to our third differences so we can get a, but to do that, we gotta go down the path. These numbers are getting a little large, so I'm going to reach over here and grab a little TI calculator to help me out with that. Okay, I got that. Okay, 72 minus 14, that's going to be, what is it, 58? 14 plus 58 equals 72. Then we have 198 minus 72. That's going to be 126. Okay, then we have 416 minus 198. So I get that here. 416 minus 198. For that I get 218. Okay, 218. And the last one to look at is 750 minus 416. That's going to be 334. Is that right? Yeah. Plus 334. Yeah, that's right. So that would be our first differences. So those numbers are already something to behold. Now for our second difference, we're going to have 58 minus 14. Well, that's going to be plus 44. And then we're going to have 126 minus 58. Okay. 26. Should be able to do that in my head. I don't know. That's going to be 68. Then we're going to have 218 minus 126. That's going to be, what is it, 92? Yeah, that's going to be 92. Next, we have 334 minus 218. That's going to be 116. Is that right? Yeah, I think so. Okay, that's going to be it. Now we go to our third differences. We have 68 minus 44 is going to be plus 22. No, plus 24. Excuse me. Then we have 92 minus 68 is going to be also plus 24. And then 116 minus 92 is also going to be plus 24. So we have our third difference here. And that's going to be equal to 24. So our third difference is equal to 6a. So that's going to be 24 is equal to 6a. If you divide by 6, 24 divided by 6 equals 4. So a is equal to 4. So a is equal to 4. So we're going to get 4x cubed. Okay. Next, we're going to have our first second difference. Okay, let me write this down. First second difference is equal to 6a plus 2b. And I'm going to go get a skinnier pen here for that. And our first second difference is 44. So 44 is equal to 6a, and 6a is going to be our third difference already. So that's going to be 24 plus 2b. So we subtract 24 from both sides. We get 20 is equal to 2b. Divided by 2, b is equal to 10. So b is equal to 10. And our first difference here, become less thing. So first difference equals a plus b plus c. Kind of run out of room here. So that's going to be 14 is equal to a, which is 4, plus b, which is 10, plus c. We have 14 equals 14 plus c. So c is equal to 0. Right here, up here, c is equal to 0. So what is our equation here? Well, we have f of x equals ax cubed. So we have 4x cubed plus 10x squared. And we have 0x, because c is 0, plus 0. So this is going to be our answer for number 9. Okay, the last one I'm going to do in this video lesson is number 11. And we'll just go ahead through the process here. We already know we have a y-intercept of 1. So I'm going to put first the function up here. F of x equals a x cubed plus b x squared plus cx plus d. So already you know d is equal to 1. Next, we're going to go through our process here. And the numbers seem smaller here. May not need a calculator this time. So you have 6 minus 1 is going to be plus 5. That's our first difference. Then we have 15 minus 6 is going to be plus 9. Then we have 31 minus 15 is going to be plus 16. Then we have 57 minus 31, that's going to be plus 26. And then for the last one here, we got 96 minus 57. That's going to be, is it 39? 96 minus 57. Yeah, it looks like 39. Okay. We have 9 minus 5 is plus 4. That's going to be our second difference. We have 16 minus 9 is going to be plus 7. We have 26 minus 16 is going to be plus 10. Then we have 39 minus 26 is going to be plus 13. So now we come to our third differences, which are going to be 7 minus 4 will be plus 3. Then 10 minus 7 is going to be plus 3. And then we have 13 minus 10 is going to be plus 3. So our third difference here is equal to 6a. So we can write our equation to the right here. We have 3 is equal to 6a. And dividing by 6, we have a is 3 over 6. So a is equal to 1/2. So a is equal to 1/2. Next, we have our first second difference here, which is 4. So first second difference equals 6a plus 2b. So let's find out what that is. So our first second difference is 4 equals 6a. Well, 6a we already had value of 3, right? That's going to be 6a plus 2b. And so if we subtract 3, we have 1 equals 2b. And so what accordingly is b going to be equal to? Should be 1/2. So b is equal to 1/2. Okay, now the first difference here is going to be equal to a plus b plus c. So I'll put here first difference equals a plus b plus c. So that's going to be 5 is equal to a. Well, a is 1/2 plus b is 1/2 plus c. So that's going to be 5 is equal to 1 plus c, and subtracting 1, c is equal to 4. So right up here, c is equal to 4. And so our entire equation is going to be f of x is equal to a, which is 1/2 x cubed, plus b, and b is also 1/2 x squared, plus cx, and c is determined to be 4x, plus d, and d is going to be 1. So this is going to be our function, our cubic function here. So this is a little bit involved. Your teacher, like I do, probably wouldn't expect you so much to memorize these formulas, but you should be able to take advantage of them. If you have a little calculator on the side like I did on problem 9, that could be most helpful. Good luck on this and your other problems, and thanks for viewing.